In this module, we'll look at memory and programmable logic. We'll introduce the concept of a memory unit. So a memory unit is where we store the binary information that can be later used for processing by the microprocessor or sent to an output device. So we can view a memory unit as a collection of memory cells, each that are capable of storing one bit of binary information, either a 0 or a 1. And it's capable of storing a large amount of data. So what we've looked at so far are flip-flops or registers for storing binary information. So it's similar to that. Each cell is analogous to a flip-flop, each word perhaps analogous to a register. But since it's capable of storing much larger information, what we might consider loading a register, we'll talk about that being a write operation, to write into data memory. So it's an operation as opposed to just a function, one function. We also have a read operation for the process of transferring information out of memory. So if we have a flip-flop or a register, once that data is into the register, it's available at the output of the register. That's not quite true for a memory unit, so we have a specific operation for that. So instead of talking about loading memory, we talk about writing it, and then we also talk about reading memory. And we consider it a unit of memory. So we have two types of memory in digital systems. We have random access memory. We use the acronym RAM for that, and that can both read and write, has both read and write operations. And then we have a read-only memory, or a ROM, and that only has the read operation. Now there's other differences between RAM and ROM that we will discuss, and you might wonder, how can you just have a read operation of memory if you haven't written anything into it? So we'll get into that as well. We'll also talk about programmable logic devices. So those are integrated circuits that can be programmed, but the programming is done by hardware and not by software. So it's by hardware that you get the information stored into a ROM device that can only be read by software. So the programmable logic device also consists of a set of logic gates and an OR gates, and they're connected by electronic paths. So we have these electronic paths, these and OR gates, and these memory types of cells. The electronic paths behave as fuses. If the fuse is blown, the path is disconnected. So originally, all the fuses are connected, so all the electronic paths to the ANDs and OR gates are intact. Some of the programmable logic devices behave as circuit breakers. So once you disconnect a path, you can reconnect it again. You can switch it back on. Typically, these PLDs, they store hundreds to thousands or millions of gates and hundreds to thousands of internal paths. So when we talk about these AND and OR gates that are connected by the electronic paths, our conventional symbol for an OR gate, for example, if we had a 4-input OR gate, that we show 4 inputs going into the left-hand side of the OR gate, whereas we're going to use an array logic symbol for our PLDs. It looks sort of like the dead fish symbol. So instead of a dot indicating that you have a connection, what we do is we have an X that indicates that there's no connection. So for this symbol here, that we see all these paths are already connected to the OR gate. If I compare the two, if I had 4 signals, let's say I have signal A, B, C, and D, then I could put A, B, C, and D. If I don't want to connect, for example, D, these are all connected because they're initially connected. If I don't want to connect it, I put an X there. If these are actually connected to some other, so this would go off to, the difference here now is this would go, that's how we'd say A, that's how we'd say B, that's how we'd say C, for example. If we had D and it just ran like this but wasn't connected, right? We could have it going across here over to someplace else. It didn't connect anywhere, so we don't put a dot. Here, if we don't want to connect D, we have to put an X. It's initially all connected. So again, the different symbology signifies a logic diagram for gate array designs. So we have different types of PLDs as well. A ROM, we said that's a type of PLD. It's programmed by hardware, and it's we call that read-only memory. We have programmable array logic, programmable logic array, and field programmable gate arrays. So these each have slight differences in their PLD designs. So the design has different strengths and different weaknesses, and we'll discuss more about the different PLDs and how to use them at the end of this module. But before we finish this video, let's just talk about the different types of read-only memory. So read-only memory itself, a ROM, that's the mask in the last step of a fabrication process. So it's all basically hardwired. Examples of that are parts of the BIOS of your computer board that you don't want to change. You don't ever want to change those. Programmable read-only memory can be programmed. So the way it's programmed is different in different types of ROMs, but it's typically it can be programmed electronically, or it can be programmed once, or it can be erased and reprogrammed again. So whereas a programmable ROM, the user can program it, but isn't going to be able to erase it. An erasable programmable ROM, an EEPROM, that can be erased. So the old ones had a little window in the front on the top of the IC, and you'd shine ultraviolet light on it, and it would basically reset up all those connections. It would erase all the disconnects. An electronically erasable PROM, that's erased by an electronic signal. That's what the old, your old flash drives used to use. Now what we have for flash is a new type of flash memory, and they're also electronically erasable. And there's different types of flash memory that are faster and used for different applications. I've provided you also some links to look more into this type of technology. We'll just talk about the structure of the PROM, not exactly how it's erased. This just shows how we have this floating gate here that works as either a programmable a NAND flash or a NOR flash drive. All right, so that's it for this video.